In section 5.1, we are going to look at compositions of functions, or composite functions. And the way we write it and the way we say it is f of g of x. And what we mean is that we take the g of x function and we use it and evaluate f when x is g of x. So, as an example, if we take f of x to be x squared, and if we take g of x to be 3x plus 2, then the f of g of x function, it means take f of x and evaluate it with g of x inside. F of g of x means f of 3x plus 2, because that's what g of x is. And this means anywhere that we see x in the f of x function, we're going to replace it with 3x plus 2. So we have x squared is our f of x function, and we're going to write 3x plus 2 squared. And your book will probably want you to FOIL that out, but that is our f of g of x function. We could replace and we could write a second example. Using the same functions, we can find g of f of x. That is g of f of x. That is g of f of x. That says everywhere that we see x in the g of x function, replace it with x squared. So we have 3. There's our x. So 3x squared plus 2. Let's look at another example. So f of g of x means f of g of x, which means f of g of x, or x minus 4, which is everywhere we see x in the f function, we're going to replace it with x minus 4. That is 1 over x minus 4, and that's our new function. So you may be asking yourself, well, f of x has a domain and g of x has a domain, so what's the domain of f of g of x? In order to find the domain of f of g of x, we have to look and say, what works for g of x, and then what works for the new f of g of x. So if I look and say, what works for g of x? Well, all real numbers work for g of x. Then if I say what works for the new function, and I look at that, are there any problems? Well, there would be a problem at x equals 4, so we say x cannot equal 4. So in this problem, the domain is all real numbers except for 4.